Hello guys, in this section 3.3 I'm going to talk about the unit circle. In here I'm going to introduce you another way of learning trigonometry using a circle centered at the origin with radius 1. That's why we call it a unit circle. Alright, so pretty much if you have any point on the circle, let's call point P x comma y, you can learn all the trig function based on the xy coordinates of that point P. Okay, so let's start from point P right here. I just randomly choose the point P on the circle. And OP is a radius, and you know the unit circle is a radius 1. PXY, so distance from here to here is x, and distance from here to here is y, right? So this is the y. And we try to bring it back to the right triangle that you guys learned before. So point P on the circle is create an angle theta with the x-axis from the origin. Okay, as we learned before, cosine of theta. Cosine is what? This angle cosine is adjacent over hypotenuse. So adjacent is x, hypotenuse is radius r right here. Okay, and that's r is equal to 1 because this is a unit circle. So basically, cosine of theta is equal to x. Okay. So similarly, what about sine of theta? Sine of theta, sine is opposite over hypotenuse. Opposite is y, hypotenuse is r, which is 1. So this is y over r, which is y over 1, which is y. So you see the use of this unit circle. Basically, the x coordinate is representing cosine and y coordinate representing sine. So many people usually draw this xy coordinate instead of writing x. This is the cosine axis, and this is the sine axis. Okay? Think of the y value, think of sine, think of the x value, you think of cosine. Alright, so cosine is x, sine is y of the angle created with the x-axis. Alright? So if you have cosine and sine, you know tangent. Oh, I say tangent, right? Tangent of theta is sine over cosine, or tangent is opposite over adjacent. This is going to be sine theta over cosine of theta, which is y over x. And then cotangent of theta is cosine of theta over sine theta, which is x over y. And secant theta is 1 over cosine theta. Cosine is x, so 1 over cosine is 1 over x, and then cosecant theta is 1 over sine theta, which is 1 over y. Alright, so you can learn the trig function using the unit circles. There's a lot of things to think of. First of all, you see that if the point P on quadrant number 1, then both x and y are positive, and that means both cosine and sine are positive. If P is on quadrant number 2, then sine, which is y, will be positive, but cosine, which is x, will be negative. Quadrant number 3, then what? Both sine and cosine are negative. Quadrant number 4, cosine positive, but sine will be negative. Okay? Now, let's use symmetry to figure out some trig identity. Alright? You can learn some trig identity, a lot of them actually, using just by looking at the unit circle. Not all identity, but the basic ones in here. Say I got the angle theta. What if I make the angle right here negative theta? This angle right here is negative theta. Okay? So angle theta, you have a point P on quadrant number 1. This is like P about Q on quadrant number 4. Angle theta, angle negative theta. You see what happened in here for sine and cosine. You see that cosine of theta will be the same as cosine of negative theta. Right? What about sine? Sine of theta is up here. Sine of negative theta is going to be what? Negative y, right? So sine of theta is equal to negative sine of negative theta. Because Sine of negative theta is going to be a negative number. I put another negative in front to make it positive. You see? So you can have some trig identity involving sine and cosine. How about a couple more? This angle is theta, right? What if I have an angle right here? For this angle, let me use red color, make it stand out. You know how much this angle is? This is theta, so the measurement of this angle is still theta. So the angle from here to the red one right here is 180 degree minus theta. If I use radian, it's going to be pi minus theta. Okay? Okay? This is called angle alpha then. Alpha is equal to pi minus theta. Theta is that much. It's the same right here, right? The whole thing from here to here is 180 degree. Then subtract theta, you got the angle alpha. And if you got the angle alpha right here, what is the same with the angle theta? Alpha is that much, theta is that much. Okay? We have the same sign, but opposite cosine, right? So we have sine of theta is equal to sine of pi minus theta. Cosine of theta is equal to negative cosine of pi minus theta. See? With some basic trig identity can be figured out using the unit circle. Okay? And of course, I just randomly choose angle theta in the first quadrant, quadrant number 1. You can draw any angle at any quadrant. That works the same way. Okay? And let me just add a little bit more than what you see in the book. You see that the x-axis represents the cosine axis, the y-axis represents the sine axis, and if you draw a vertical line that is going through that point 1 right here and parallel to the y-axis, this is actually the tangent axis. It's really tangent. Means what? Say you have an angle, point P right here, right? And if you extend the line segment OP into intersect that tangent axis, the distance from here to here will give you tangent. Similarly, use a different color. If you draw a line that's going through number 1 on the y-axis and it parallel to the x-axis, this is the cotangent axis. Okay? And green color. From here to here is cotangent. Alright? So far, so good. Now let's talk about some special angles. If I got the angle theta equal to 0, if angle theta equal to 0, the point is right here. So look at this. Cosine is 1. Sine is 0. Alright? If I got the angle right here, 90 degree, then what? Cosine of 90 degree is 0 because this point right here is that 0, 1, right? X0, Y is 1, so cosine is 0 and sine is 1. The point right here is 1, 0, and that means what? Cosine is 1 and sine is 0. Alright? So, let's talk about tangent. If you have a point right here, and this is the tangent axis, point right here, tangent of 0 is equal to 0. That's good. What about tangent of pi over 2? Pi over 2 means 90 degree. You move the point P all the way to this point up here, and what? Tangents go to infinity. So, out of class, we got tangent of pi over 2 is undefined. Okay. What if I have the point P right here? This one is at -1, 0. So cosine is -1, sine is 0, and this is our line. So tangent is 0, and cotangent is undefined. Okay. Let's see it. A point right here, point -1, 0. So in here, cosine of pi 180 degree is -1, and sine of pi is equal to 0. So tangent of pi is 0 over -1 is 0. Cotangent of pi is -1 over 0 is undefined. Alright, so you can have any point. Basically, you don't even need to think of tangent. Just sine and cosine, then you can figure out tangent, cotangent, and secant and cosecant. Alright? And of course, Pythagorean theorem works in here as well, almost all the time. Point P right here, this is x, this is y. Pythagorean theorem say what? X squared plus y squared, square of the side plus another square of the side equal to 1. X squared means cosine squared, theta, and y squared means sine squared of theta equal to 1. It works, okay? The same way as before. Alright. Let's talk more about the domain and the range of the trig function. Let's talk about sine. You can have any angle, right? Sine of theta. In general, could be any angle. Sine theta. Theta could be 0, could be negative angle, could be positive angle. You can go around the circle as many times as you want. So sine of theta could be any angle. What about the range, the output? Doesn't matter where you put in the point P. The y-coordinate of the point P gonna varies all the way from -1 to +1. That's most. Okay? It's never be bigger than 1 or less than -1. So sine of the angle theta will always be somewhere between -1 and +1. Same thing, doesn't matter how you move the point P along the circle, the x component is always somewhere between -1 and +1. So cosine of theta, same thing, is always somewhere between 1 and -1. Okay? It's not the same for tangent, guys. This is the point for tangent, and this is the tangent axis right here. When you move the angle, say right here, this is tangent, right? Tangent could move from 0 all the way to positive infinity, and if you go the angle move the angle this way, the tangent value can go from 0 all the way to -infinity. So tangent of theta is going to be somewhere between, let me write it carefully, -infinity less than or equal to tangent theta is equal to positive infinity. When do we have tangent equal to infinity? If the angle is, you see, moving this way, the angle is getting closer and closer to 90 degrees, and this tangent point is going to keep moving up further and further. When the angle reaches 90 degrees, tangent value go to infinity. Same thing, if you go the angle this way, let's go to -infinity. Okay? And same thing for cotangent. If the angle gets close to 0, the tangent point is going to go all far away to the right, to infinity. The angle getting close to pi/2, then the angle is going to go to -infinity. Alright? Same thing, -infinity less than or equal to cotangent, less than or equal to cotangent of theta, less than or equal to infinity. Okay? And you have the, you can use the unit circle to figure out some special angles using geometry. But I claim that we covered that already. Say for example, you have sine of pi/4. When we talk about degree, this is the same thing as sine of 45 degrees, and this is equal to √2/2. Cosine of pi/4 is equal to sine of 45 degrees to √2/2, and applied to our circle is right here, 45 degrees. Okay, this is the angle, 45 degrees. Okay, so sine and cosine is this much. This is √2/2. This is √2/2. Okay. Sine of pi/6, which is the same thing as sine of 30 degrees. Pi is 180 degrees, so pi/6 is 30 degrees, right? 30 degrees is that much, about that much right here. Okay. Sine is 1/2, and cosine of pi/6 is equal to √3/2. All right. Just give you some basic, typical, popular numbers that you guys are gonna work with a lot. So it's easier faster, I would say, if you just remember those angles. Then another one, how about sine of pi over 3, or pi over 3 is 60 degrees, is sine of 60 degrees, I meant. Sine of 60 degrees, which is root 3 over 2, and cosine of pi over 3 is 1/2. Okay? You only need to learn the angle of sine quadrant number 1, you move to angle quadrant number 2, you change the sign, right? Say quadrant number 2, value of, remember something called the coterminal angle. Sine still positive, but cosine negative. So if you have like an angle of 120 degrees, you think of 60 degrees, right? 120 degrees, and when you think of 60 degrees, but what sine is the same, cosine is going to be the opposite. It's a negative number, okay? And this is pretty much about a unit circle. So there are many ways to study trigonometry. Some people prefer algebraic way, some others prefer the geometric way, and I prefer geometry. So you see, whenever we think of trig, this is what we have on top of my head, the unit circle. And then any angle, I have sine, cosine, and it's helped me to figure out some basic trig functions. Of course, for the harder trig identity, which we're going to learn later on, we need to learn more. But for now, the basic ones is in here, and that's good. Let me double check if I missed anything. Okay, that should be enough for the unit circle. So we still have time. Let me move on to the next section, 3.4. We're going to talk about the linear speed and the angular speed. Linear speed and then angular speed. Okay. So here's the story in this section 3.4. You know what it means by linear speed. Linear speed is how fast you drive in a distance, right? Say you drive, linear speed is denoted by a little v. V stands for velocity. Linear speed v. Linear speed. V is equal to s over t, or some people usually denote d over t, where s is the distance and t is the time. It's not really a new thing, so I kind of go fast in here. So you have, whenever you have a distance, you divide by time, you have the velocity of the speed. It's what we call speed, right? How fast you drive. Now, what is angular speed? Angular speed is talking about how fast you're rotating. Okay, so it's instead of distance at a time, now you talk about the angle at a time. So say if you are right here, let's just start with, and you travel an angle of 120 degrees. This is 2 pi over 3, I think, 180 degrees. Let's talk about right here, 2 pi over 3. In 5 seconds, what is your angular speed? And then same idea as the linear speed. Instead of taking the distance divided by time, what do you do? What you do is you take the angle divided by time. It's going to give you the angular speed, because we don't measure how far you go. We measure how fast you change in the angle, okay? The angular speed. So angular speed is denoted by omega. It's like a W. It's equal to the angle theta over time t. Okay, see? This is changing distance over time. This is changing the angle over time. You got the angular speed. Okay? And what is the connection between the velocity and the the linear speed and the angular speed? It depends on the radius, right? So you know that s from here to here is equal to, this is the angle theta, is r times theta. Let me write it on the book with theta times r. Okay, so you think of velocity, it's going to be s over t, which is theta times r over t. And you see what theta over t is. This one right here is the omega, so this is omega times r, or r times omega, see, right? Whenever you have the velocity, the linear velocity, you multiply by, whenever you got the angular velocity, you multiply by r, you got the linear velocity. Or you got the linear velocity, you divide by r, and you got the omega. And this is the relationship v is equal to r times omega. I think it would be better if I give you an example. So let me give you one example on this section. You have a clock. Okay? We have, say, basically two hands on the clock. This is number 12 right here. This is 3, 6. This is 9, right? Can you calculate the angular speed of the short hand? Okay, so I have short hand and I have long hand, right? How do you calculate the angular speed? So, how fast is going to change the angle per time? So, you have a short hand right here, and it's going to travel for the entire circle in how long? Was that 12 hours to go over the entire circle? Was that right? Right. And the entire circle is 2 pi, 360 degrees. So for the shorthand, the angular speed omega is equal to 2 pi over 12. 2 pi is in terms of radian, which is the angle. Okay, it's travel all the way from here to here. Okay, a complete circle, 2 pi. How long does it take to travel for the shorthand to travel the entire circle? 12 hours. So 2 pi over 12, which is pi over 6. This is radian per hour. Right? 2 pi is in the radian, and the time is in terms of hour. Is that right? And of course, if you want to change the decimal, pi is 3.14159, and you have the speed. Okay? What about the long hand? The long hand gonna travel with a faster angular speed, right? The long hand, the angular speed is the entire circle is 2 pi. But now, how long does it take for the long hand to travel for the entire circle? It's only take it 60 minutes, which is 1 hour. So if you wanna calculate in terms of hour divided by 1, this is 2 pi radian per hour. Okay? That's about the angular speed. Now, let me talk about the linear speed. We are talking about the tip right here. That point right on the top of the shorthand and the point right on top of the, this is for the long hand and for the shorthand. See how fast that points are moving around. Okay? So if the shorthand is doing a complete circle, you see the tip is traveling with this circle right here. And the long hand is traveling with this circle right here. Okay? So, which one move with the longer distance? Of course, the tips of the long hand gonna be moving with the longer distance because we have a longer radius, so it's gonna travel with a longer circumference. Whereas the short hand has a shorter radius, so it's gonna travel with a shorter circumference. Is that right? So how do we calculate the linear speed? We have to know the radius or the length of each hands. Okay. Say if short hand, say the radius is equal to little r. For the long hand, the radius is how about big R? I call this one little r. There's too many things in here. This little r. and this one right here is big R. Whatever the unit you can have, just put in there. Okay? So you want to calculate the linear speed, you have to calculate the distance, and the distance is travel divided by the time. So for linear speed, right? Linear speed. Let's talk about the shorthand first. Shorthand. Shorthand circumference of the smaller circle is 2 pi little r. And then divided by what? 2 pi little r is right here. Divided by the time is traveled along the circle, which is 12 hours, which is pi times r over 6. I just take away the 2 on the top and bottom. For the longhand, and this is the linear speed. Say a little v, right? For the longhand, the linear speed is v is equal to 2 pi, but now the circumference, the radius is not little r anymore. It's going to be big R, and of course divided by not 12 hours to complete the circle. The longhand only needs 1 hour. So this is 2 pi r. And the radius, the unit here is whatever the length over the hours, okay? Would be meter per hour or centimeter per hour or feet per hour, whatever, okay? Same thing here. And you see that this V right here is little r times omega, where omega is the angular speed for the circle, and then this V here is capital R times omega, where omega is the angular speed of the longhand. And you know that this omega in here is equal to pi over 6, right? This omega here is 2 pi. Alright, and this is just an application of unit circle, any circle in general, using the radius, the length, and the angle to measure the linear speed and the angular speed of any object moving. And hopefully the example has helped you to understand the idea a little bit more and help you to do the homework. One more time, if you have any question, please ask. Thank you guys.